recording soon. Okay, here we go. So 6.1 to 6.3 study guide. We're just going to kind of go through and talk about the things that we've done so far. So in 6.1 was a lot of stuff. The first thing that we did in there was we kind of did a lot of matrix vocab. So we talked about things like dimensions. So when we had things like this, we could say that the dimensions were 3 by 2. It's always rows by columns. That was a major thing from there. We did addition and subtraction. And remember, you could only add and subtract matrices that have the same dimensions. So if I've got matrix A and matrix B, and they have the same dimensions, then we're good to go. So if this was 4, -2, 3, 5, and this is -1, 0, 2, 7, you could go A minus B. And then we would just take the elements of matrix A and match them up with B, and we would subtract. So we'd get 4 minus -1, -2 minus 0, 3 minus 2, 5 minus 7, that sort of thing. So we would get that kind of result, and we'd do the same thing for addition, but we would add instead. Okay, so we did addition and subtraction. We did multiplication by a constant. So instead, if I took matrix A and I wanted to know what is 3A, that would just be 3 times 4, -2, 3, 5. And we would just take the 3 and distribute it to all of them. So that would give us 12, -6, 9, and 15. Okay. And then we did multiplying matrices. So we had things like A times B. And we needed to have the same inner dimensions in order to multiply them. So this was a 2 by 2. This was also a 2 by 2. In order to multiply them, remember these need to be the same. And then the resulting matrix you get will be the outer dimensions. Okay, so take a moment and just to practice, go ahead and multiply these 2 matrices. Once you've got it, type done in the chat. All right, as you're working on it, if you want to check your work as you go, you can look at and see what I've got going here. And if at the end you get -8, -14, 735, you got it. Okay. So on this one, just to recap really quick what we did, we take the top row and the first column, and that becomes our top row first column here. We go 4 times -1 plus -2 times 2. Then the second one, we take the top row second column, and that becomes our top row second column here. So we go 4 times 0 plus -2 times 7. Then for our bottom row first column, we take the bottom row and the first column, and we go 3 times -1 plus 5 times 2. Then for the bottom row second column, we take the bottom row and the second column and go 3 times 0 plus 5 times 7, and we get 35 there. Okay, so that was multiplying matrices. You can also do that using a calculator if you've got a TI calculator or a Desmos Matrix. Either way, you can do that. Let me find another piece of paper. Okay, so multiplying two matrices was kind of starting to get into the 6.2 stuff. So that's about where that started. So 6.2 was technically multiplying matrices and then finding inverses, determinants and inverses. So when we were doing determinants, or wait a minute, sorry, 6.2 was a bit of multiplying matrices, but then we went back to 6.1. Because technically the whole thing of 6.1 was, like if you actually looked in the book and went, okay, this is 6.1, it didn't have all that stuff about addition and subtraction and dimensions and all of that stuff because they kind of assume you already knew that for some reason, because of where our book starts. So we added that all in and called it 6.1. And then also in 6.1, we had solving systems. With matrices. So this is where we had that Rho Echelon Form and everything going on. So we had Rho Echelon Form, which was if we have a matrix, and let's say it's an augmented matrix, and usually if you're in a calculator, little dots don't appear. It's just kind of to organize your thinking. So remember Rho Echelon Form, if you've got a 3x3 over here and the augmented part's over here, that was where you have ones on the main diagonal, and then you've got zeros down here. And then everywhere else can be other numbers. And then we had reduced Rho Echelon Form. Which was the same idea, except it takes it a little bit further. Then all of these were zeros. And these were the values of x, y, and z. So we end up with an identity matrix over here, and then our values for x, y, and z. And this one was the one that was more useful to us when we were solving systems of equations. So if you had a system of equations, let me find one that actually works real quick. So many sticky notes. Okay. We could have something like x minus 5y plus 8z equals 7, negative 8x plus 3y plus 12z equals negative 9, 5x minus 4y minus 3z equals positive 9. So if we had something like this, we would take our system and we would put it into an augmented matrix where we had 1, negative 5, 8, 7 on the top row, negative 8, 3, 12, negative 9, 5, negative 4, negative 3, 9. And this was the augmented part over here. And then we could stick that into a calculator. And we would hit RREF. And then it would give us something in reduced Rho echelon form with X, Y, and Z. Numbers here being the values of X, Y, and Z. Okay, so that was one way that we had to solve systems of equations. The other way that we had to solve systems of equations involved inverses and determinants. So we're going to jump back to 6.2 and talk about, we talked about inverses and determinants. Okay, so inverses. You could only invert something if the determinant was not equal to 0. And so if we had a 2 by 2, A, B, C, D, A inverse was defined to be 1 over the determinant times, you'd swap D and A on the diagonal, and then you'd switch the sign on B and C. And the determinant itself was defined to be A times D minus B times C. Okay, so that was what we needed to know about how to find inverses and determinants. Otherwise, in a 3 by 3, we used a calculator. Okay. So then the last thing that we did was what we did on Friday in that ed puzzle. So if you did not do the ed puzzle on Friday, or you did not finish the ed puzzle, that would be a good thing to do. So looking at 6.3, that was solving systems with inverses. And so if we took that 3 by 3 system that we had before, where we had x minus 5y plus 8z equals 7, negative 8x plus 3y plus 12z equals negative 9, 5x minus 4y minus 3z equals positive 9. If we took this and we wanted to solve it using inverses, we made a matrix A, which was the coefficients of all of these. And then X was the variables. And then B was the constants. So we set up something that looks like this, where we'd have 1 -5, 8, -8, 3, 12, 5, -4, -3, times the matrix XYZ, and that would equal 7, -9, 9. So then to solve this, we multiply by A inverse on both sides. So if this is like A, this is X, and this is B, we would multiply and get X equals A inverse B. And the order of multiplication is very important. If you do B times A inverse, it won't work. Okay, so to get some practice with the calculator and everything, take a moment and do this one using inverses. Find A inverse and multiply by B. Once you think you have it, type done in the chat. All right, as people start to finish with this, if you are using a TI calculator, remember to get to matrices, you just go second matrix. To edit them, you go over to edit. You make your matrix A as a 3 by 3, and you type those numbers in. Then you quit and go to matrix again and type matrix B to get the same thing. And then to do A inverse B, you hit A, and then you hit the X inverse, so the X is a -1 button, then second matrix, and you get B, and then you hit enter. And if you got 12, 9, and 5, so X is 12, Y is 9, and Z is 5, you did it correctly. If you were doing it in Desmos Matrix, I want to show that way real quick, just in case some of us aren't quite done yet. Give you some extra time. Desmos Matrix is what we want. You would go new matrix, 3 rows, 3 columns, and then you fill it in, do the same exact thing. So 1, -5, 8, -8, 3, 12, 5, -4, -3, no, 3. And then B, oops, new matrix. Add a row, get rid of a column. 7, -9, 9. And then you would type A inverse B. And you'd get the same thing. Okay. So that was pretty much everything that we have done so far in this class math-wise. Are there any particular things that we want to go back to or go back over at this point? Okay. And as you go through this, maybe if you were writing down the study guide and everything, look back through, and if there's anything in particular that you want to practice again, like make note of it for yourself, put a little star next to it or something. This is your study guide, help you get ready for the quiz tomorrow. So while you're doing that, I'm going to talk a little bit about what our schedule looks like going forward. Okay. So we've done everything that we need to do during for chapter 6 right now. 6.1 to 6.3 is all we're going to do out of chapter 6. So starting on Wednesday, we're going to go back to chapter 1 and start in chapter 1. So we're going to do 1.1 and 1.2 the rest of this week. So that's what we have coming so far. And we should expect probably another quiz next Wednesday on 1.1 to 1.3, Wednesday or Thursday, I would say. Just to have a heads up. Other than that, oh, that's what we need to do next. Okay, so as far as this assignment goes, it's called Flipgrid Notes. We're going to do a quick Flipgrid where you just show me what your notes look like. I want to see what you guys have been doing, and so you guys are going to get credit for taking notes. And the way it's going to work is it'll be something like this. So let's say that the study guide was your notes for the chapter. You would just hold up your notes to the camera and go, okay, this is my 6.1 notes. This is my 6.2 notes. This is my 6.3 notes. Or since I didn't really ever say 6.2, you know, say what the titles were, what you called your notes. This will not go as, like not everyone in the class is going to see this. I'm going to moderate this one so that only I see them. So if you see it as hidden or something like that, know that you submitted it and it's all good and everything. It's just going to remain hidden so that not everyone gets to see your notes. So yeah, I'm going to be the only one that sees those. And if you would like to, if you don't want, you know, me to see your face or whatever, you can even hold up your notes in front of your face if you like. I don't care either way. I just want to see what you've got for notes in a way that's kind of quick and easy to look at. Okay. Any questions about what the Flipgrid Notes thing is going to look like? Eden says, oh no. All right. Other than that, the assignment for today is a practice quiz. And it's going to work very similarly to the way the 6.3 assignment worked. You can make a copy of the Google Doc if you want, since it's in Google Docs this time, and you can do it on there if you like, although it's hard to type matrices. Or you can print it out and do it if you have a printer, or you can do it on your own paper. However you would like to do it is fine with me. This should give us a good idea of what we're going to see on our quiz. So we've got writing an augmented matrix, recognizing Rho Echelon Form, solving systems of equations. If it doesn't specify, like on number 3, it does not specify. It says using, but we're going to ignore that. You can pick the method you like the best. So if you would like to row reduce, you can. If you would like to use inverses, go for it. Let's see. And then we've got, you know, going a minus b, a times b, multiplying by a constant and subtracting, kind of combining those. Oops, I did that one twice. That should have been v times a. Sorry about that. And then solving this solving a system using an inverse matrix, solving a system of equations using whichever method you would like. So yeah, there we go. There are 10 questions. You guys have the rest of class to work on this. If you have questions, feel free to stick around. There is no exit ticket today. So you guys are free to head out unless you have questions. I will be on here for the rest of the class period. So if you do have questions at any point, hop back on and we can talk. Yeah, have a good one. There probably won't be a word problem on the quiz, but I kind of liked that one because it was already written in the format of a matrix pretty much. So you could pretty much toss these into a matrix and hit row reduce, and it'll give you the answer. So I left that one in there. Yes, if there's work to be shown, please show your work. Yes, you can use Desmos Matrix on anything involving a 3x3 matrix or more. I'll put that at the top too.